And the next topics, the trip generation and attractions is finished. And the next topic is one, then the trip distributions. Trip distribution models is also there are several ways to estimate the trip generation, trip distributions. It is very complicated. I don't want to further. Let's make me more, just in cases I would like you to open the Excel files. Step 2. The what? Step 2. But it will this table is originally made by me. Some training material made by the Tokyo universities. It is published on websites. So then this figure shows about their how to develop the future OD tables from the various way. Growth patterns, average growth pattern to estimation model and Detroit models and Flater models is developed. I can't explain everything in English from my knowledge. However, can identify from the formula. For example, you can see to the list figure what items is different. Yes. Then, for example, you can based on the result of the future and current trip generated and attractions, some growth states is modified. And so the growth pattern for the trip generation and attractions is applied. The growth ratio by the OD tables is developed. And there, until the result is repeated, till that is the adjustment value must be nearly to 1. Such kind of repeated calculations, right? To go to the presentation materials. I don't need to. I don't think that all of you need to understand how to develop the OD tables in the picture. However, there are several ways for the generally speaking, the trip distribution estimation models have 2 categories. First one is a present pattern methods. Present pattern method is just to write the present OD patterns. So it means current trip patterns will be applied also for the future trip pattern. It is very easy way. Then the annual growth models and the Detroit models, but I'm not sure. I don't explain everything. However, how to estimate is described in these pages. And not so different among this following 3 ways. And the Flater models is most popular ones, and they're based on their so-called their growth patterns of the trip generations and attractions. Then the travel trip, future trips also will be developed. And Strada also have functions to execute the Flater formulations. So in the next sessions, I will explain about how to use this Flater models. Yes. Then there is when the present pattern is more easy and more convenient to use. However, there is one of the problems for the present patterns. Yes. Of course, as I explained, present patterns will assume that the current trip pattern will be applied for the future trips. In that cases, it can't cope with the change of the land use. For example, in the current list, there is a major trip is made from the CBD to Westland or existing urbanized area. However, for example, if the new urban town or new development area is developed, this trip, so many trips must be there among between the CBD to this proposed new town. However, if there is no trips as of today, such kind of trips also cannot be modernized. In those cases, especially for such kind of so-called emerging country or emerging cities, then the applying the present patterns is a little bit difficult. And especially Tokyo or Japan or already developed cities, and the patterns is not assumed to be changed drastically. So the present pattern is sometimes used. So for example, you can see that this figure, there is a large river. There is one bridge among the cities. Then if the new bridge is developed between these sections, city B and C, so many trips also must be developed. However, then if the present pattern is developed, then the trips between the sections without bridge can go without bridges also will be more increased. And the trips between this area is not so increased. This seems to be doesn't seems to be realistic in case of the considering the future trip patterns of the cities. Next one is so it is called the modeled trips trip distribution models is developed. Then the most typical one is gravity models. As gravity meaning and this model is from the Newton's law of gravitations. Yeah. What's the relationship between the Newton's models and people's trips? Actually, no one can prove it. However, this is I'm not sure why it is considered as the most typical way for estimation model for the distribution model. However, anyway, no one can observe, can prove it. It is not reasonable. So, in that cases, all attendees, I would like all attendees to understand it, that this so-called illogical situation. So I would like some of you will be the good so-called researcher to develop the new model. But I don't want to. Yeah. Then the gravity models is to use then some explanations and the trip generation subtractions and inversely as a zone impedance, distance times or generalized cost will be the explanatory variables for the trip distributions. This one is also in the Excel files. I showed some models for the gravity models. Oh, seems to be very wants to show. Once I don't want to say something. However, for example, there are some present is there. Then among the OD pair, vision destinations, for example, travel times is developed. From 1 to 1, 8 minutes. From 1 to 2, 70 minutes. 1 to 3, 22 minutes. Yes, it's developed. Based on this results from the all and destinations, then there are some circuits based on this result and the zonal impedance and the filter trips in the same as previous sessions. Then some regression analysis is developed. So the relationship between the travel trips between A to B and the travel time between A to B first developed. Have you followed it?
Use the Excel to check the formulas.
Then yes, then from this existing current travel time by OD pair, based on some future transport investments, the travel times between A to B or A to C, sometimes improved. Then from this result, the travel times, this formula is applied, and the trips between A to B, A to C is formula. And the next times, and the value is adjusted. Then the final OD tables is developed. This is a very, very simple explanations about how to develop the trip distributions models. But I'm not sure. Does anyone understand this step? Well, everyone having different vision.
I would say generally, what I understood is you need to constantly iterate for all the models. That's the one thing I understood. And constantly iterate until you almost achieve one. Once you achieve one, then you know you've gotten your answer. Yes. That's the one thing about that I'll take it.
Then you can go to C to B2. I don't want to say that, but this one is actual OG tables from this project. O meaning the origin area, origin zone. P is the destination zone. And C, distance kilometer is the distance between zone 1 to zone 49. Then the number of trips, this one is observed number of trips from zone 1 to zone 49. Then, I don't want to explain this, however, this is a trip generations, two-home trip generations at zone 1. Then, this one is trip attractions for the zone 49 levels. Then, this column showing the zonal impedance. You can see. Then this value is developed as a parameter of the zone impedance. So D square 0.35 is this zonal impedance. Then later in these results, yes, following the formula, then this one. Modeled trips between A to B, between zone O to zone D, 1 to 49 is formulated. Then after Freighter calculation, this is made by the other Strada software, so I didn't explain yet. So then the base to this result, the figure is converged into that. So as a result, then this table shows the X is the actual traffics, the trips, number of trips by zone between original destinations, and Y is the modeled trips. Then after the Freighter's conversions, the trips, the R square means show the relatively high correlations for the trip distribution models. This is very, very basic one, and no one can understand completely about the trip distributions and models. However, Based on these results, the trip distribution models is developed. Where everyone is apparently confused about the basics compared with the trip generation. But no one can, yes. For me also, it was very difficult to understand everything. So, but from the practical approach, I needed to learn it.
So okay, I just have a general understanding that we have two areas, let's say like this area and this area and that area. And that area is generating some trips. This area is generating some trips, and this area is generating some trips.
Yes.
More trips will be where the impedance is less. Let's say the impedance is the distance between him and me. So you expect to have more trips here.
Yes.
And less trips laterally.
Yes. Based on the average trip distances for the right travel vehicle, for example, vehicle availability, car user tends to take longer trips than other trips. Normal trips.
I can give a practical example. Let's say I've been employed by Namata. Maybe I was living in Dagoretti, and I was working there, but now I've been employed by Namata. So the first thing I would want to do is to try and see where closer to Namata can I live. So that, because this is a trip I'll be making every day to work. So naturally, I'll want to look for a place around here. Maybe I'll go to Westlands and I'll check the distance between maybe Hamza and Namata. Then if the rent there is closer to...
No one dropped that.
Yeah. So if the rent in Hamza is similar to the rent I was paying in Dagoretti,
Everyone.
and I'm single, then I'll move to Hamza. So naturally, I'll be making short trips. So when we check the phenomena, we'll notice short trips are being made more times on long trips. Then similarly, so this is one example that our habits, this is natural that you would want to make short trips. But then again, say I have a wife now and I have school-going children. So now it becomes a problem. So the same scenario. I live in Dagoretti. I've been employed by Namata. Now I want to make everyone comfortable. Me and my kids, I don't want them to go far from school. So what I would want to do is I would want to balance the time it takes for everyone to go to their places of interest, be it school or work, versus the cost. So naturally, it will come naturally. I'll want to see how I can reduce both. So I think that is the gravity model. Yes, that is the gravity model. That is how it works. It assumes you want to be closer to your place of interest, closer in terms of cost and in terms of time. So I think in a nutshell, that is the gravity model.
So you can go to top 5. For example, you can write 0.1. Like this, the figure changed. It's got that.
Yes, that was 0.73. Yeah, 0.73 is 0.71. So 0.73. Yes.
Yeah. Like this, then the most, so the high R squares value is selected. The following that is field formula. And then you can go back to first presentation. This one figure shows about how to estimate the distribution models and this page shows the developed trip distribution models and the parameters for the car available group and the non-car available groups. Then But this one is pointing areas. Is the parameters is generally car available group show a very lower values of this lambda. Lambda means this the parameters the zonal impedance functions, and need to be explained for example this, and it means just the car available groups tends to make a longer trips. Then if this lambda value is higher, they will make a stop the trips, the shorter distances, because of the this is showing the zonal impedance is very high. The non-car available groups is very sensitive about the low zonal impedances. The car available groups is that make a more trips for the longer trips. The people wants to move to other places. So as a result, then they have very strong so-called they're not so sensitive about the zonal impedance.
So if I can use the same example I was using.
Yes.
So let's say again I still live in the Doreti, get employed by Namata because I have a car, I wouldn't it will not occur to me to move because I already have a car. But if I was using a public transport, then I would want to move closer.
Okay, that's the reason as to why most probably people who own cars tend also to live far from the city.
Yes,
Kitengela. People who don't own cars want to live nearer where the workplace is.
Yes. But this is a considered class.
Yes. So for Nairobi metropolitan region, you can say that is one of the phenomena that most people, most people who live in Syokimau, you'll find most of them have actually built. And that is because when Nairobi was growing, those who now afford vehicles, we actually did some analysis, and actually in Nairobi, people tend to start affording vehicles from around 4 years of age. You'll notice when it gets to around that age, that is the same age you want to build your own home. And because you want to build around Syokimau, the first thing, once you build, the first thing you want to own is a car. So you can be coming to work. So that phenomena explains why the metropolitan region, the traffic is very influential to the CBD, because you have most people who actually live outside the CBD because it was affordable for them to live. They've actually bought cars, now they want to come to the city. So this is one phenomenon. Then the other phenomena could be that some people, that was their rural home, so they don't pay rent. So he'd rather still just live far, but just buy a car. You see. So that is the second phenomenon, traffic in the metropolitan region.
I have one question.
Yeah.
So is this where the transfer service coming?
Transfer service.
Transfer service means
survey, transfer survey. Yes, it can help to identify major where you can actually spot major terminuses in how can I put it? Informal, informally, we have routes right now in Nairobi that informally we're not aware of. For example, you have people who live in Utawala but work in Westlands, which is very odd. So you'll find if they can get a direct service, like right now I was told in Utawala there's a direct service by Supermetro to go to Westlands. So this is a phenomenon that you can only capture if you go to the field. You'll realize actually people don't want to transfer. If they can have direct routes, the better. So the idea is to try and minimize transfer. This is what Nairobi County was trying to do with their route network, to avoid people transferring from the CBD, because the CBD right now is the major transfer point. And it's unnecessary sometimes, because if I can avoid the CBD, for example, someone can be living in Ngong Road, but they want to go to Syokimau, but there's no direct connection, public transport connection from Ngong Road to Syokimau. So this person is coming into the CBD unnecessarily. So he's coming into the CBD to drop off from one bus and pick another one to go back home. So they're causing unnecessary traffic in the CBD. So if we can reroute him to avoid him coming into the CBD, then we've solved the traffic congestion, you see. So the idea is to try and minimize the transfer.
And one of the issues currently, my model, the variables of the distribution model is distance, not time. In that cases, for example, when as he proposed the estimate of the transfer service, or for example, the good public transport service, more internationally, for example, high-speed railway service or airplane service is developed, such kind of travel time variables is more better. In that cases, you need to update the travel distance models using the explanatory variables as for the travel times, not travel distance. And if such kind of model is developed, and if some transfer service or some other transit service is developed, so the origin and trips between the specific origin and destinations will be enhanced. That's why this project is very necessary for the future. Such kind of, you can go to such kind of conclusions always. So why I selected the distance, but it is more so-called accountable. Travel distance is not so far from the real situation, I think. Travel times might be different because of the project. And for example, if the BLT is developed, I'm not sure the frequency is 30 minutes or 3 minutes or 5 minutes. In that case, it will very affect about the model choice or travel distance models. So I just selected the travel distance for the city area. So anyway, according to your conclusions or your policy wants to validate. So need to update the travel model choice, and to order non-advance. This one also very, very annoying descriptions about how to adjust the trip distribution models when you can't reach to the good conclusions. However, I also doesn't want to explain about these pages in this session, so that I would like you to review it if you have some faced with some problems.